everyone. In this video, we will talk about digital transmission. Following are the characteristics of digital transmission. A computer network is used for communication of data from one station to another station in the network. We have seen that analog or digital data traverses through a communication media in the form of signal from the source to the destination. The channel bridging the transmitter and the receiver may be a guided transmission medium such as a wire or a wave guide, or it can be an unguided atmospheric or space channel. But irrespective of the medium, the signal traversing the channel becomes attenuated and distorted with increasing distance. Hence, a process is adopted to match the properties of the transmitted signal to the channel characteristics so as to efficiently communicate over the transmission media. There are two alternatives. The data can be either converted to digital or analog signal. Both the approaches have pros and cons. What to be used depends on the situation and the available bandwidth. Now, either form of data can be encoded into either form of signal. For digital signaling, the data source can be either analog or digital, which is encoded into digital signal using different encoding techniques. The basis of analog signaling is a constant frequency signal known as a carrier signal, which is chosen to be compatible with the transmission media being used so that it can traverse a long distance with minimum of attenuation and distortion. Data can be transmitted using these carrier signals by a process called modulation, where one or more fundamental parameters of the carrier wave like amplitude, frequency, and phase are being modulated by the source data. The resulting signal, called modulated signal, traverses the media which is demodulated at the receiving end and the original signal is extracted. Number of signal levels. This refers to the number values allowed in a signal known as signal levels to represent data. Bit rate versus baud rate. The bit rate represents the number of bits sent per second, whereas the baud rate defines the number of signal elements per second in the signal. Depending on the encoding used, baud rate may be more than or less than the data rate. Talking about DC components, after line encoding, the signal may have zero frequency component in the spectrum of the signal, which is known as the direct current component. DC component in a signal is not desirable because the DC component does not pass through some components of a communication system such as a transformer. This leads to distortion of the signal and may create error at the output. The DC component also results in unwanted energy loss on the line. Signal spectrum. Different encoding of data leads to different spectrum of the signal. It is necessary to use suitable encoding technique to match with the medium so that the signal suffers minimum attenuation and distortion as it is transmitted through a medium. Synchronization. To interpret the received signal correctly, the bit interval of a receiver should be exactly same or within certain limit of that of the transmitter. Any mismatch between the two may lead wrong interpretation of the received signal. Usually, clock is generated and synchronized from the received signal with the help of a special hardware known as phase lock loop (PLL). However, this can be achieved if the received signal is self-synchronizing, having frequent transition in the signal. Finally, cost of implementation. It is desirable to keep the encoding technique simple enough such that it does not incur high cost of implementation. Data rate versus signal rate. The data rate defines the number of data elements, that is bits, sent in 1 second. The unit is bits per second. The signal rate is the number of signal elements sent in 1 second. The unit is baud. The data rate sometimes called the bit rate. The signal rate is sometimes called the pulse rate, modulation rate, or the baud rate. Our goal in data communications is to increase the data rate while decrease the signal rate. Increasing the data rate increases the speed of transmission. Decreasing the signal rate decreases the bandwidth requirement. Now this is the pictorial representation how direct component can be transmitted. Now here we have a comparison between signal levels versus data level. In A, we have two signal levels and two data levels, whereas in B, we have three signal levels and three data levels. On DC component, a signal with the DC component, we have only 0, 1, 0, 0, 0, 1, and a signal without the DC component that we have, you can see the uh, difference between the amplitude between the two A and B. When the voltage level in digital signal is constant for a while, spectrum creates very low frequencies. These frequencies around zero, called DC components. It presents problem of a system that cannot pass low frequencies or a system that uses electrical coupling. Now here we have an example. A telephone line cannot pass frequencies below 200 Hz. Also, a long distance link may use one or more transformers to isolate different parts of the line electrically. For these systems, we need a scheme with no DC component. Thanks for watching.